Yeah, hi everyone. Today we'll be talking about Kotlin again for Advent of Code 2025 solution for day one, part one, just to showcase you the code that I written in Kotlin, in Java, and in Scala, and in Rust. So basically that's it. So 4 languages, uh, basically the same approach to solving a problem, just different syntax. I will show you that all of 4 languages now support the style of programming that I prefer personally. So here you can see the style of programming that I like, the pipeline programming, the data-oriented programming, functional, and all of that stuff. You can just read it. So, and the description as in previous video, you just can grab and see and read it, maybe supply this to LLM and try to understand what is going on, or just watch other YouTubers how they approach the problem. But the idea of this video is not to explain the problem itself, just to show the code, the solution of it in different programming languages. So the first one is Kotlin. So as you can see, the Kotlin is very concise. So we have in Kotlin we declare constants usually like this. If you want to hold some kind of number, some kind of constant as a private, something that is encapsulated in this file. Private means that we do not expose it outside of this file. Const means that it's constant, it cannot be changed, you cannot just reassign it somehow. But actually, I think there is something more to this constant. Okay, so there is more to this. You can read in BileDone that const is like static in Java. For variables that are known at compile time, you just declare like basically constant value, and they say that this constants actually can be inlined. What it means that if you do like this const val, then it is appeared here in the bytecode or something like that. But this is something that programmers should not even consider even thinking about, I think. All right, let's see what it's. The next stuff is that, of course, we have main function here. So in Kotlin, it is really uh, convenient to do some operations on resources. So if you want to read some file into the memory itself or consume lines of this file, so this file is I created here under resources folder, and in Kotlin it's really convenient. You just grab an object, Java class, get resource, read text, or else resource not found. So this is really powerful. So basically first thing is when we get resource, it returns a platform type. Why? Because this is from Java. So you can see get resource, it returns URL, but on which class? On class called class we get in resource. And when we actually consume something from Java, from Kotlin, consume something from Java, then the type returned as platform type, denoted by this exclamation mark. It means that it's kind of non-deterministic thing. Kotlin at this point does not know if the value can be null or cannot be null. So that's the platform type is for. So in Kotlin we kind of can have 3 kinds of type, right? So platform types that again nullability information is not available. Then of course nullable type, for which we absolutely need to somehow check for null. And then we get non-nullable types in Kotlin as well. So there's 3 types. Here we get the platform type, and kind of understanding like, and it is probably on the programmer side itself to check whether what is the returned value, right? we just go to here and just understand from the documentation, can it return null or not. So here it says return a URL object or null if no resource. So you kind of understand from the documentation that this method can return null. So we absolutely need to somehow handle null. We can, most of the time Java documentation does not lie. But if you do not, because in software development, in projects, for example, I participated in several projects. When developers write documentation, it probably means that this documentation expired at the point it is written, and then it's the case like nobody even cares, because under tight deadlines, just forget about the updating documentation. It's kind of hurts maintainability and readability and everything in the long run. But for Java sources itself, like the Oracle or whoever develops this Java, they provide this documentation and they care about this, so we kind of can absolutely rely on the documentation stating something in plain English. But always we can recheck that this method can return null, so we're absolutely sure. By the way, you can see that the code is absolutely garbage. I never ever write such code in production. Just nonsense. Okay, but this is something that implemented in the Java itself. So we just get in the resource here, and it returns the platform type. Means we need to somehow, we check that it actually can return null. That's why we need to somehow handle null. And in Kotlin there are multiple things we can just explicitly check for null, like equals null or not, like most programmers do. But in Kotlin we have much greater thing, is that this operator, like this, it means if we have null, then we skip this and then propagate down to Elvis operator and call in this error. If not, then read text, and then just this expression returns either read text, or this expression does not return. It just, here we error. It means here error, just throw in an exception somewhere. Here throw illegal, so it never computed. So it means that, so this is the expression, right? So how to understand this expression? We just trying to read this file, get in resource as this file, and try to read the text. If the resource is not null, if the file exists, and today this is the case, right now it actually exists, and then reading the text and then returning whichever text returns, that's the type of the expression returned here. So if read the text returns string, then string is returned. Otherwise, probably nothing is returned, because we're throwing an exception here. So suppose we have this file, we read the text, so this expression returns the string, and then what we do is we call in this line sequence on the string returned by that. But actually it does not really make sense. We already read the file lines by lines, but the file itself is really little, like it's just 4,000 of lines. It's just nothing for JVM, so we are fine. So here line sequence, just it's a really convenient method to return a sequence of lines of the file. So here we read to string this file, this whole file, then just call in this line sequence, so it returns line by line like this, the first line, the second, third, fourth, and so on and so forth. So that's the thing, we have this line sequence on string, And here the cool part of IntelliJ, why I absolutely like this IDEs from JetBrains, is that they highlight the return type of this line sequence. So it's really convenient to see. We actually do not need to specify, and we cannot specify right now here like that, this is the sequence or something. But this is something that done by IntelliJ IDEA itself. So right, we get this kind of sequence or stream or logical like sequence of something, some elements, sequence of lines, and then what we do is map to stream. So what it does is that if we have here in some cases like this, like that, like the trailing or leading spaces, then they will be trimmed like that. So we will end up with sanitized input holding only what we really care about, without gibberish, without noise. So this is just the part, like you in production, it's like I constantly use streaming because we have not consistent data. So it's really powerful and cool. So far so good. We just composing a data pipeline, from the file itself. We just streaming, like we just sequencing all of the lines of this file, you can see. And most programmers, what they do is they do some fucking looping like this, like they say var2 blah blah blah, if else, if else, if else. This is complete gibberish, complete garbage code. If you see someone doing looping without any reason, most probably they are just not really competent enough. So here we return the line sequence, then trimming, then filtering is not empty. What does that mean is not empty? Is that if we somehow by any chance have here line that consists of only spaces or something like that, then this filter is not empty. After actually trimming a single such a line, trimming will reduce it like this, and after that filtering is not empty, just removes this from the lines in memory. So again, this is really convenient this is the pattern, right? This is the cool pattern to eliminate just sanitize the input if the file contains some gibberish. Then what we do is parse move delta. So what does that mean? We kind of mapping each element. After we return sequence of each line like this, we will end up with elements like this, like this, like this. And that's exactly the time for us to parse move delta. So we retrieve here text, but text is not really a great variable name. I will say this is actually a line. And then here, and we can actually do it private because we do not expose this function anywhere outside. This one as well. So what we do, line drop 1 to int. What does that mean? Line, we have line, right? So here line 1, so basically this is line, but if we took the single line, you can see it is composed by R and 20. So we can split at this point, retrieve this one and this one. But actually we can also do what we just drop first, and then we will end up with the number itself. You can see that on the first position there always will be some kind of R or L. So here we just drop in that part. R or L dropped, we end up with number itself here. So this expression returns a string which actually contains a number parsable. safely, absolutely safely to be parsed. And here we just do it to int, to parse that shit into int variable. And then this is kind of lightweight pattern matching that Kotlin provides. So here we just line first. What does that mean is that this is the first one, right? This is the char, the character here, ROL. So we will have here ROL. For example, this is air. If it is air, we just do an amount and returning it back. Otherwise, minus a. So this is like left or right. If we rotate left, it means minus amount. Otherwise, amount itself. So parsed, then scan. Scan is super cool feature, or just primitive from functional programming. Just a function to given some kind of state, we compute on each operation on each. So basically, scan will loop through sequence of integers, and the initial state we can actually have here whichever state we want initial, but here for this problem itself we just use 50 because this is by the program, but by the problem itself they say that the dial starts pointing at 50. That's why we have here this 50, and then operation is just function, reference to function. So what it does is that given the position itself, so the first position is 50 because we supplied here the 50, so here it will be 50, and then delta is the sequence the sequence element itself. So for example, here you can see that we will have multiple we parsed move delta depending on left right. We just say minus amount or amount, or 0 if it doesn't, but it will never be computed because the file does not contain anything other than L or R. So this pattern match on L or R. So here scan, as I said, next position, the first one will be 50 because we supplied as a first as an initial state, and then delta is the element itself, so it will be like 109, then 40 or if you're starting from the very beginning, it will be 22, 26 minus 20. You got the point. So here we will, so this scan under the hood, it given the 50 is initial, it computes the next position, the next state, but it does that under the hood. So this is really powerful because we don't need to do some kind of var and then state and then looping through it like most programmers do, using some imperative loops with if-else conditions. But we do not need it. We just have this higher level thing, scan, higher level function, because it has as an input another function, which is here passed as a reference to a function. So the responsibility of this function is to compute the next state each and every time, given the state itself and the delta, which is next element, it computes a next state. So when it is complete, of course, it also can be considered as a whole expression. So what it does, as I said, we have in here as an input, right, left, right, rotate right or left. And when we're rotating, basically plus plus some number or minus some number. We kind of also here, we just making sure that this like when we do minus and plus, this expression does not overflow 100. So this is like closed dial, like we put in a position like range between 0 and 100. And when we computed this actually expression returns a list or something like that. I do not really exactly. Okay, it returns a sequence of elements. Here somehow IntelliJ does not specify that this is the sequence returned here. Like this, it's specified, but here it did not. It does not specify that. But we have here a sequence of elements, and then we count how many of them are 0 and then just print line. So when I run this, okay, you can actually, okay, let's wait. Okay, this is the number that I got, and that's exactly the number that is here. Your puzzle answer was this one, and this is like this program works. It completely satisfies my established rules of programming, pipeline programming, data-oriented programming. So it's really simple. Like in plain English, we just describe what we want. That this is the power of Kotlin. That we do not actually need, like in Golang, for example, to use some kind of loops and variables and use this for e blah blah blah. This is like, I do not know, the schoolboys how they program, but in Kotlin we do not need this garbage. We can just declare using the like English. Just say, give me that, read from file, read text, or else throw error, then line, then map, and so on and so forth. So we kind of declaring what we want. It's like declarative, like functional, like. Of course, Kotlin is not 100% functional, but it right now has everything to do this. Next, I wanted to show you the Java code. It does exactly the same. If you run, and here we have input is the same, but here in Java I just declared as a variable instead of file. But if I just copy and do like that, it is the same. You can see it is the same as here. Okay, perfect. And in Java, what is cool is that now we do not need actually to declare a class inside of which we declare a main method. We just can declare the main method itself in the file. And this is something called, I think, implicit classes or something like that in Java. But the thing is that right now we can do like this void main. It's similar to what we have in Kotlin, like fun main. Okay, so basically we do the same. We do input. Oh, I can actually to compare it side by side. You can see Kotlin and Java. So here, instead of reading from file, I just use the variable or constant, and then strip ident is the same as, okay, in Kotlin we also can do strip or not. We cannot. Okay, so here we retrieving line sequence from Kotlin, but in Java it's just lines. And stream, of strings is kind of can be thought as the same as a sequence of string. In Kotlin, it's not really the same, but the concept is kind of the same. In other languages, like in Rust, you can encounter some kind of thing as iterator, so it's kind of logically the same concept, just to be able to declare some kind of sequence or array of elements or list of elements, but it's lazy list. It's not computed eagerly. So here the same, like it looks the same. Like this map stream is the same as in Java. Then filter is not empty. Here we do not have convenience in Java, so we declare this like that. In Kotlin it's much more readable. We just say string is not empty. So in Java we do. So it's kind of adding some mental. We need to add some kind of mental energy to be able to firstly see that line is empty. We call in it, and then after that we negate this boolean. And then map parse move delta, and here is the same, like this is the same function as this, but in Kotlin we use a return when. When is an expression. Expression means that when we compute something, like the expression is something that can be computed to a single value, and since it's a single value we just can return it. The same situation in Java, but in Java it's switch, just different keywords. And in Kotlin it's much more readable. We say line first, meaning that from string we just getting the first element, but in Java it's like that, text char at, a bit not readable as Kotlin, but still okay. And here we have case, but in Kotlin I do not need. So basically syntax is different, but intent and everything is the same. Oh, and also in Kotlin it's much more readable if you're coming from some functional languages, when we drop in the first element and then just ending up with the whichever string is after that element and parsing to it. But in Java we firstly do text substring begin index, kind of we skipping the first element. So this is the skipping the first element, but it says like text substring, which is not really showing the intent that we need to skip the first element and get whichever we have after the first element. So I think Kotlin wins in this thing. So when this expression returns, we parse in integer parse int, and that's it. So that's pretty much it. Also here gather. So gatherers is something that was added since 24 of Java. So at the moment of shooting this video, we have Java 25, but gatherers were added in 2024 to be. So why I used it, to be able to use the scan function, which is not available in Java in anything else other than gatherers. So this is just to mimic what is available in Kotlin. In Kotlin it's much more concise. We just, on sequence itself, we have scan function that we can call right away, passing in function. But in Java we need to, you can see, call this gather method and pass in the instance of gatherers like that. Like it's a whole like machinery and additional syntax to write a simple thing as in Kotlin. So here we supplying the initial state, as here the scan wants actually supplier, and yeah, it okay, yes, supplier, and then passing in the scanner function itself, or lambda, or how to call that, say, like with two elements, position and delta. Again, position, it's something that the state, we can think of it as a state, the current state, and then delta is the element itself produced by that stream of integers. And constantly we do the same operation as in Kotlin, but just using the different syntax. And then here computing this is integer equals to 0. In Kotlin, of course, it much more concise, because we do not need to specify that in it and then asterisk, or how to call that, or arrow. We just we implicitly have this it in Kotlin, and then printing like this. But in Java, we do filter and count. But in Kotlin, we just do in one operation, just count, and that's it. We do not need to specify filter and then count. And one thing in Java is that we cannot continue this data pipeline by doing something like in Kotlin. Basically, we cannot do like this, because it's Java. So what we end up is that we computing this, how reader reads the code, right? It reads line by line, line by line, line by line, determines the line or count, and then understand that the whole expression. So here expression returns the long value. It again, through all of the code, it returns to the variable declaration. So this password is getting the value of the last expression. So you can see that in Java, people read the code like starting from the first position, reading, encountering this, and then returning it back, seeing that this is long password. And then from password again, we do here and IO print line. So it's like I do not know how to call this, like I think it's the stupendous, like the bullshit. Like when I see the Kotlin is available and we can just do line by line, just compute expression, reading like a book. So the Kotlin code we can write as a book. We do not need to constantly jump like idiots, like some kind of I do not know, like the babies. We do not play cards. We do not play in childhood in the playground. I'm here to write the business applications that do some business for users and for customers, that they should be happy. But in Java right now it's just nonsense. Okay. So I do not see the reason why should someone pick Java. Maybe because programmers are completely brainwashed, because someone said they need to use Java, because their bosses said that they must use Java, and then obey just like slaves, slaves. They are slaves. So the thing is that, but in Java they also wrote this IO class, which is util class that holds a bunch of static functions. This is really funny. Like what for? We already had system out print line like this. Why you supply me to the same capabilities, the same thing to achieve the same result? Just because we don't want to type additional dots. That's because like this is they I mean they have Valhalla or something like projects that they want to release, and also they have JEPs to implement nullable and null restricted types as Kotlin does. But why they implement something which does not have much leverage? They constantly say we want to implement something that has a big leverage, like the huge impact. Using some low resources, we implement something that will change the programming let's landscape or something like the I think that this is the meaning of their speeches like that. But well, and this is Java, nothing else. And next one, I show one more JVM language, which is Scala, in which the code looks the most sexy, most concise. So you can see in Kotlin we have fun main, in Scala we have like this one. We can of course do not specify the unit, the return type of this, but in Scala it is the compiler or IDE, as you can see, it says, "Hey man, just apply it. It's good." So that's basically it. And in Scala, it's much more concise, right? We're just doing source from resource, and then put this expression into using resource, on which we call this make string. So it's kind of the same like retrieving a string from string itself from the file. So it kind of erase the whole file, and this is all right in applications if the file is not really huge, like so. But then we split into lines iterator. So this is exactly the same as line sequence, but here of course the Scala type is returned, which is iterator on string. Then we do absolutely the same as in Kotlin. We just mapping, filtering, not empty, map parse delta. And note that how in Scala we do not need actually to do like this. So as in Kotlin. In Kotlin we do like this, but in Scala we do not need. So it's kind of more pleasant to write the code, which is we already understand that the parse move delta is already declared in this class. We do not need to hustle with those colons. Like the syntax is not really beautiful in Kotlin in that manner. But what can we do? And then in Scala we have scan left, which is the same as scan in Kotlin. And here of course we passing in the next position. So you can see that in Scala it is much more like you treat functions as a first class citizens, meaning that the expression 50 and next position is also expression, like which you can pass in, pass out. Everything is much more smoother, I would say that way. Like it's Lamborghini. When you use Scala, it's like Lamborghini. Of course, I do not have Lamborghini, but I think that the feeling is probably the same. If you are a programmer, if you came from something like Java or, God forbid, Golang, then of course Scala is much more simpler. You can write that code in simpler, using simpler ideas. And here, in Scala, of course, you can do some kind of magic on type classes, implicits, and stuff like that. But still, as Martin Odersky said, just care what you do and make the code simple. Do not over-engineer. So here in Scala, we have this parse move delta. And note that it's absolutely the same as in Kotlin. So we drop in one and to int, and the same like much. Here we have much. In Kotlin we have when, but in Java we have switch case. In Scala we have much case. So that's the 3 JVM languages here. And also, if we go to Rust, here I present you Rust on the right and Kotlin on the left. So you can see that Rust being compiled language into machine code, not JVM, not bytecode, no, without virtual machines. But the code looks like similar, absolutely similar to what we have in Kotlin. Of course, with some headaches like some asterisks and ampersands and stuff like that, but still it kind of we can sacrifice actually such things for like forgive the Rust, because Rust compiles under the hood. Of course, it's just we paying some money, something to achieve much more in Rust. I mean, from the syntax perspective, it's maybe more contains more something that is low level things, low level concerns as memory management things for compiler, for borrow checker and all of that stuff, but still the code looks really great. So as in Kotlin, reading from file or else panicking or throwing an exception, in Rust we also can do fs read to string. So here fs, I don't really understand, I think it's called crate or something like that, but I treat it as a module, some kind of file in which we have some helper functions. So on module on or crate fs we have read to string declared here, which reads the file into the string. You can see we're supplying exactly the same file as we had in Kotlin, Scala, and Java. And here we're supplying from Rust, we're reading this expression, and here we have unwrap or, which is, you can see, it's if we read successfully this file into the memory, then it's okay. Otherwise, it's just default string, which is empty string. We can do also unwrap like this, but it is not, I mean, if you absolutely want to crash our program, absolutely, if we do not have file here, or file is corrupt or something that we cannot read from this file, then we can just do unwrap, because this read to string, it returns a result holding string or no or error. You can see. So we absolutely need some kind of handling. We cannot just say give me the content of the file, as here in Kotlin we do. It actually returns either we have content of the file, either error, from which we can somehow, as I said, okay, so basically you understand that we have absolutely the same code doing absolutely the same, and the point is that we have line sequence, and we have lines, map and filter, and everything is supported by Rust. And even we do not have this gibberish as in Kotlin, we have parse move delta with this semicolon, so how to call that, or colons. We're just doing like in Scala, and then passing in scan function and the next position. Of course, we have here some different mechanism that we in place, we mutate in the state. So basically, this I don't really proficient in Rust, but I think that this next position somehow now has the reference to a mutable, like I think it's borrowing, mutably we borrow this position, and then here we the reference, something like that, and then putting the state into this mutable state using the same formula as we do in Kotlin, but it's in Rust, and then returning some position to satisfy this option return type. So this borrowing exists only for the duration of the scan exists. So scan is actually the who owns this mutable state, and this next position just borrows the mutable state and then just does its dirty things to the state, writing into the state and then just doing its stuff. And then we have filter function. Filter function to filter the things that are with 0. So this is probably also called something like the reference or something like that. I'm not really proficient in Rust, but the code looks almost the same, but with some wrapping or wrapping things.